So good morning. Welcome to this session. I'm Fu Qiao, and this is Wang Xu. We're both from China Mobile. I'm the project manager for the China Mobile Experiment Network, and also I'm working in the OpenNFV community. And Wang Xu is working on the NFV infrastructure, specification, testing, and integration. So in today's presentation, we would like to introduce some of our work on NFV and SDN, the experience we got when we do some large-scale trials and experiments, and how we try to solve all these problems. We also got help from Qi Liang and Li Tao for this presentation. This is the basic content for today's talk. I will first try to explain the best practice in China Mobile, where we try to construct what we call the telecom integrated cloud in several provinces in China. And then we will explain the automatic onboarding system, which will help us reduce the integration and testing work. And finally, we can show a few demos that show this whole system, how it works. So first, begin with NFV. I guess everyone in this room might be quite familiar with this concept. NFV, network function virtualization, it has been the basic concept of it is try to move the traditional telco services into virtualized cloud. By doing so, we hope that we could reduce the whole cost and also bring the agility to this whole network. Actually, NFV has been widely experimented and deployed around the world, and operators are continuously moving traditional network functions into their virtualized cloud. For example, in China Mobile, we began our virtual IMS trials like 2 years ago, and our narrowband Internet of Things trial like last year. And also, we built our what we call the experiment network. I will introduce more details about this work in the following slides. And here I also listed several of the most common seen VNFs that now has been tried and deployed in the NFV scenario, like virtual APC, virtual CPE, virtual CDN. These are all considered quite widely. And here is a little glimpse of the China Mobile's trip to NFV and SDN. We have a brand name for our future network based on NFV SDN. We call it Novonet. We announced this brand name back into 2015. And then based on NFV SDN, we hope that it could be a completely new network with virtual resources and agile network structure. We hope that it could provide network users with scalable resources and open API to utilize. And like I mentioned before, we began the IMIS trial in 4 provinces in 2015 and the NB trial in 6 provinces in 2016. And also, we have what we call the Novonet experiment network begin late last year. We hope that this is a brand new network built for experiment and testing in NFV at SDN. The network currently includes 4 provinces, and we have multiple VNFs considered and tested in this network. This is our future network architecture. Like you see, we structured the whole network into what we call TICS. It's Telecom Integrated Cloud. It is a standard unit with unified hardware and software infrastructure. And multiple VNF servers will be deployed in the one TIC, and they will share the virtualized infrastructure. So we categorize TIC into what we call the core TICs and edge TICs, in which core TICs mainly support control plane services and edge TIC support forwarding and data plane services. And the edge TIC will stay much closer to end users. We actually did a calculation how many core TICs and edge TIC we finally will have when finish this network reconstruction. And we count on all the users we now have, and also we consider the roadmap of each virtual services when they will go into ticks, when they will be virtualized deployed. And then we now have quite approximate data is that we might have 50 to 100 core ticks nationally, and the edge tick will be more than 1,000. So you can see it's a large number. And this is how the details of tick. As I mentioned, we see that it is a standard unit. So it will have limited number of design templates. It will have unified hardware models, and it will have standard network design. I would like to share you more details about the templates. We see that there will be multiple VNF services of different kinds deployed in ticks. So we think that maybe for each different kinds of VNFs, we might have a little different template for them so as to provide enough virtual service for them. For example, we may have a template for control plane services like virtual IMS, which will stressing mostly on the compute capability. And there may be a template for data plane service stressing on data forwarding capability, like what we now have as virtual BRAS, virtual EPC, and things like that. And also we may have a template for the edge services, maybe stressing on the low cost and lightweight. And maybe for storage services like virtual CDN, we may stress on the storage capability. So the three key features for ticks we say is that it's a standard unit, it is template-based, limited number of templates, and it has to be easy to copy so that we can finish the integration of all those thousands of ticks outside. So I tried to zoom a little into each tick, and you can see that they are constructed with custom hardware and virtual software platform. But we also see that during the transformation, we can have some physical network functions still co-located in the same tick. And also, we think that OpenStack, of course, is chosen to be as the manager for the virtual infrastructure. And we also consider that the orchestrator, the VNF manager, and the EMS should be deployed in the core tick only, and these should be on the VMs, so they will quite largely simplify the network design for our tick. And also, of course, SDN is used for both within tick and between each tick. So I will introduce more about the Novonet experiment network, which I'm mostly working on, and show you how the problem we're facing. This network is built now in 4 provinces, namely Beijing, Shanghai, Zhejiang, and Guangdong. And we actually have 7 data center sites that are included in the network. And by now, we have 14 ticks constructed. VNFs, as I mentioned, include narrowband Internet of Things, virtual BRAS, virtual CPE, and enterprise bandwidth on demand. This EBOD things might be a little bit unfamiliar to all of you, but you can consider it as a virtual CPE for the enterprise users. The problem we actually have is here. We have 9 virtual infrastructure vendors, 5 VNF vendors, 3 orchestrator vendors, and 4 SDN vendors considered in this network. So you can see it's totally a mess. It's almost impossible for us to mix all these things up. So in phase 1, most of the integration testing work were done manually, so which cost us almost like 9 months to construct these 14 ticks. So that's why we decided that in phase 2, which began this October, we will try to use our automatic system to do so as to reduce the complexity and immense labor. So you may have to question why we have to have so many vendors. But I can give you some explanations. You know that China is a huge company. We have lots of provinces. It could be impossible for one infrastructure vendor to support all these provinces. They do not have enough human resources. So that's why we think that we at least have 2 to 3 infrastructure vendors that could help us do this. So how how to make this decision is very hard. So that is one of the mission for the experiment network, to at least have all these vendors that we can consider inside and do some integration testing so that we could get the first-hand experience on that. So this is also how we integrate this tick. After the planning and configuration page, we do the OpenStack deployment, and then we will have infrastructure testing so that to make sure that all these virtualized resources is okay, it fits my requirements. And then we will have our virtualized service deployed and do some service launching testing to make sure that the service is ready to launch. So when we do this manually, we do it in weeks. This is when you have already done it before, you have enough experience, but you still need weeks to do so. And we hope that using this automatic system, we can reduce it to minutes. So here comes the what we call the automatic onboarding system. What we actually target is we hope to provide this system to the operators, maintainers, actually in each provinces. We have like 30 more provinces. There are a lot of operators, maintainers here. They don't know. They know nothing. They know little about NFV, SDN. They actually do not have much experience deploy OpenStack. So how we can help them to actually integrate thousands of ticks regionally? That's why we hope to provide this tool to them to help at least reduce the workload. So as you can see, the integration of tick actually includes lots of components from different vendors for us. And the manual integration will lead to huge workload, and it's almost impossible for us to copy the work. And also different from traditional network where we just purchased the bulky hardware and we put it in our central office, and then at least it can work because we have already tested it before during the procurement. But now you are purchasing a software, even though you have done a lot of detailed testing before, when you go to, it's case by case. When you go to this DC, you have to test it before you can actually make sure it is ready to launch. So onboarding test is something that is specifically required for future TIC network. And also, we hope that this, like I said, this automatic integration and onboarding system can provide standard process and tools for integration onboarding test for multiple vendors, so that the operations in provinces might be quite easy. And also, we hope that this will make the whole TIC easy to copy and reintegrate it, so that the whole templates, the tools, the experiences can copy from province to province and will make the work much easier as the time goes. So this is the whole system overview. We hope to, we actually use Jenkins now to do the workflow management so that we could integrate it, lots of different automatic tools, and they are quite agile to use. We now have like 3 categories of tools. One is automatic testing, which we do the onboarding testing things, and the other is automatic integration, which we will integrate a lot of installers from different vendors that could help us to install OpenStack from different vendors. And also, we will also want to provide some tools to do the auto configuration, so that you can do a lot of configuration works also automatically. And also, based on Jenkins, we can provide the pipeline mechanisms so that you can define a kind of pipeline that could help you to work the integration and testing in a single pipeline. And also, we would like to define the UI that is simple and easy to understand for operators and maintainers from telco base. This is also very important to our maintainers in provinces. So I give more details about the automatic integration, but we will have more slides explaining all these things afterwards. For the auto integration, we hope that it could be compatible to multiple installers. So now we would like to present a generic configuration files to end user, so that even though we have different installers, but the end users can only see a single configuration file, and we will have a translator to help them to translate into different one. And this is, by this means, we hope that the operators, they only need to learn one single configuration file, rather than know different process for different installers, which actually is a nightmare for us. And another thing is for the automatic testing. We actually utilize test frameworks from both open source and commercial products. I can introduce more in the following slides. So this is the lab overview. We actually built a lab and several platforms to actually do this automatic system. Like I said, we use OpenNFV test frameworks in our infrastructure testing. So we kind of build a continuously downloading things from OpenNFV. And then we have 3 ticks, I think, included into the automatic system now. We actually have 1 tick that could do the onboarding testing automatically every day. And now we have finished develop more than 150 test cases. And we can show you a demo after that, after these slides. So I will give you more details about the auto testing part, and then Wangshu will give you the detail about the auto integration part. For the auto testing part, we now consider both infrastructure testing and virtual EPC testing. For the infrastructure testing, it is based on the China Mobile infrastructure testing specifications. So we have more than 200 cases, including functional, performance, availability test cases on infrastructure. And we try to translate these man's written specification into test cases that could run in our automatic system. And now we utilize the test framework provided by OpenNFV Yardstick. I can give you more explanation of that project in the following slides. And also for the virtual EPC testing, this is actually the first try we have to do some service testing. It is based on our specification, of course. And we figure out that we might need to utilize the automatic tools from Exia, Spirent. They could help us to do a lot of automatic work. So this, we also have a picture here show the whole structure of this auto testing. And here comes the Yardstick. Yardstick actually is a performance testing project in OpenNFV. We choose that because this framework, it actually provides us quite rich and easy to use RESTful API contexts and scenarios, which help us develop all those functional test cases quite easily. So we choose this framework, and also we are contributing to the back into the OpenNFV community. And I give you more details of the infrastructure testing cases in case some of you might be interested in. We now have finished more than 100 cases, but mostly functional test cases, which includes the functional testing of both hypervisor and VMs. For the hypervisor, most test cases focus on the virtual resources that it could provide, like virtual compute, virtual storage, virtual network. And for the VM, we mostly test the management capability of VM. And also, we have did some performance testing utilizing the Spirent iTest chassis, I think. I'm not sure. So we are doing the network forwarding performance testing, whether with or without DPDK SROA, how the network performs. And also, we are now working on the concurrent operation testing. And for the availability testing, I myself is the PTL for the high availability project in OpenNFV. Within this project, we actually have focused on the HA test case development for like 2 years. We have done more than 10 test cases on HA. And there are already some test cases that we can directly utilize in our automatic system, but also we are proposing more for the F release for OpenNFV. Like we are proposing the VM HA, which means that the VM can self-recover itself when failure happens in either host or the servers. And also we are proposing SDN controller and SDN devices HA. We hope that this work can come out for the F release of OpenNFV. And here's more details about the virtual EPC test cases. We are now cooperating with Ixia and Rebecca to cover the functional test cases, about 20 more test cases. And also we are working on more test cases for availability and performance. Here is like the topology for virtual EPC testing. We use the Excel chassis to simulate the different modules in EPC. And I also give a quite simple appearance of how the test case results looks like. These are for the functional testing, so you can see it's only pass and fail. The result is quite easy to show. But we are kind of working on the performance testing, and we see we could add more curves and tables that show the more detailed performance test cases. So I will invite Wang Xu here to introduce more about the integration work.
Thank you, Fu-Chiao. Hello, everyone. My name is Wang Xu from China Mobile. I want to introduce something about auto integration and testing experience of OpenStack in China Mobile. First of all, let me introduce something about auto integration. And as you can see in the diagram, we have built a system to integrate OpenStack in our lab. As you can see, we use Jenkins and Compass, which is open source installer in OpenNFV community, to deploy OpenStack platform, which is Wind River Titanium cloud. And I think this is the first time to use Compass for NFV to build a commercial product OpenStack platform. And as you can see, the components are Jenkins and Register Pose and Compass core. And in the right side, we have PaaS, which is Wind River. And the features are it supports multiple installers, and it unifies network and environment configuration, and it is Jenkins plus Ansible driven. And here's the process of the job. As you can see, the user triggers a job, and then the job is subnet to the Jenkins master and slave and to the Compass. And there are some interactives between Compass and Wind River controller 0. And after that, it will go to the, it will deploy the Wind River compute nodes. And after that, all the job ends. And the Jenkins dashboard configuration and Jenkins dashboard configures and trigger Wind River Titanium deploy job. And in the deploy and test, Compass drive Wind River Titanium to deploy, including PXE provisioning Titanium Controller 0 operation system, and set up Titanium Controller 0, and Titanium Controller 0 provisioning compute nodes operation system, and to call Wind River Titanium RESTful API to set up compute nodes and unlock them. For the basic test, the job can create basic resources like image, networks, flavors, and it creates a virtual machine and wait and SS login to the VM and execute the basic commands. And finally, it claims the resource created by the test. And then go to the automatic testing. Here's the architecture. We use Jenkins too. And in the shell, we first do the Git code updating and then clean the environment. After that, we select test cases. Finally, we execute them. In the Docker container, we wrote several test cases in Ansible and Yardstick, and go to the NFVI and controller and those virtual machines. Jenkins job configuration is to define the test, and use Docker container as a test environment, and it will verify the installation of NFVI. And I will show you a demo video about auto integration and auto testing. Here's the Jenkins, and you can see a job. WRI means Wind River System, and we built it. And you can see it's running right now. And we go to the console, and it will show some details of the job. And we can see it use IPMI to start up the server. It is a physical server, and it is controller 0. And we can see it's starting up. After a couple of minutes, you can see it's starting up. And right now it is installing operating system. Well, after that it will install OpenStack package to the controller 0. And it is rebooting right now. The operating system installation is finished. And right now you can see in the console, it is installing OpenStack and configuring it. And it is waiting for the configure controller to complete. And it is right now is waiting host to get online. And we can log in. Now it's finished. We can go in, log into the Wind River Titanium server right now. So here's the GUI of Wind River Titanium server. And we can see controller 0 is finished, and it discovered 2 compute nodes, but they are offline right now because we haven't installed anything in it. And it will bring those 2 compute nodes online. Yeah, you can see those 2 compute nodes is starting up, and they are installing operation system. And after that, they are installing OpenStack package and do the configuration. And it is set up in host storage. Yeah, they are unlocked. Okay, after the unlock, it will bring those 2 compute nodes online. As we can see, they are online right now, and they are rebooting. Okay, after the rebooting, they will become available. As you can see, the storage is all right. They are rebooting. Yeah. After rebooting, they are available right now. And we do the basic testing. As we can see in the instances, the script will create a virtual machine called demo1, and we can see is running test case. And we can see the virtual machine is spawning. And go to the network topology, we can see a network is created. And yes, external network is created. And after that, it will delete the virtual machine and network we created. Yeah, the virtual machine is running right now. You can see it is deleted by the script, and the result is success. And it runs 49 minutes on master. Okay, here's the automatic integration, and next one we have auto testing. You can see we use Jenkins tool, and here's a job NFVT, which is testing. We go into it, and we can see it runs every day in the morning. And we can see the configuration, the project name, and see those parameters. The test cases YAML files. And we can log into the slave nodes to see the test cases. They are all running in a Docker container, and we can see the NFVT Docker container ID, and we can go into the container. And right now, we are in the container right now. We go to NFVT, and we can see several test cases we wrote. And we can pack them into a Docker container image to bring everywhere we want to test it. Okay. Let's see, the other parameter is repeat time. The default value is 1 time. And we can label the slave node. That is what we log in just right now. And after that, we run it every morning. And here's the commands. We can see the configuration, like prefix and container ID, affix, and then the testing begins. The report HTML file, and update nodes, environment configuration, and the cleaning of environment. And then run the test cases. Well, you can see the dir and the prefix. We set it is JNVT66, and the repeat time will be 1 time defaultly. and the report. After that, we clean the environment and to copy and testing result HTML to the slave host. And we wrote the report HTML, and the report we will send to those two email address. Here's HTML, the report HTML file. You can see the style, and well, here's the configuration of the job. And we build it with parameter. We run all of the test cases. Build it just one time, and we build it. And we can see it's running right now. And we go to the OpenStack platform, and we can see we can see the instances. 3 virtual machine was created, and networks. Go to the network topology, and we can see it is changing. Because yes, you can see the network is changing. We create new networks, and the scripts will attach those VM we created to the network. And we can go to the console to see the result of some detail of the testing. And we run all of this YAML test case, and we can see in every test case we can see the detail output, and it creates virtual machines, and the virtual machines are these 3 virtual machines. And after that, we delete them and delete the flavor, and we can see the recap. It is still running. And we can see the previous jobs we finished. Let's see the console output of the jobs. Okay, we can see it is finished, and the result is success. And we can go to the testing report. Sorry, it's Chinese, but you can see every single test case is the result of them. And it will send email to me, and we can see some detail of the running report. And this is the log. And you can see in the HTML style. Okay, here's a demo of the auto integration and auto testing.
Okay, thank you. I guess is there any questions? Otherwise, yeah, please. I'm sorry, I can't hear you clearly.
You guys did it in 9 months, which you said is a long time, but you managed to do it for 1 billion people in multiple provinces over a country. And like, I can understand that the vendor mix was really put it down to not just like what could deliver what, but the fact that each vendor probably had one thing that did well and 9 things that did terribly, and so you had to choose multiple vendors. Was that the case?
Yeah, actually, but the case actually is these 9 vendors, they all have their own advantage.
Do they have to be Chinese vendors?
Not necessarily.
So you could use like VNS or whoever else. Could be a US vendor as well as a Chinese vendor.
Yeah, we have vendors abroad. Yeah. Probably just the main vendors for infrastructure now. You can count them. It's about 9 or 10. Yeah, but most of the infrastructure vendors, they also have resources in China. They can support this kind of testing and even real deployments.
The other question I had is that, like, at the end of the CD where you do all the testing, is that image ready for deployment, or do you automatically deploy that image that or clients that into production, or is it just, you know that that VNF will work once the test cases are finished, and then you can deploy it as you need it, or does it deploy it into a TIC or early infrastructure automatically?
You can choose. You can integrate. You can deploy OpenStack and then launch your service, and when you do a final onboarding test, and the service is launched. Or otherwise, you can do the infrastructure testing first before you launch the service. So the whole kind of process, it is not decided yet. This may be defined by each province how they will require this thing should be done.
And I guess, why did you choose Canonical's OpenStack versus the other vendors like Mirantis or Red Hat?
Canonical, I don't think they have services in China, so they are not in this test.
Ubuntu before running OpenStack. That's why I asked the question.
What?
Like, it seemed to be that you're running Ubuntu's version.
Yeah, but it is actually an open source version.
Yes, no, I understand
Yeah.
that. That's why I asked the question. Like,
Yeah.
why did you go with a different vendor?
Yeah, we did not show in the demo, but we also have the automatic testing on Wind River, H3C. Yeah, they're also on the vendors' infrastructure. Yeah, please.
I have a question about VNF orchestrator. Yes, I have a question about VNF NFV orchestrator and the SDN controller, because I think that's the brain of the brain. So it must be one system for the whole provider. But I just wondering, you have multiple vendors for the NFV orchestrator and the SDN controller. Now how can you select multiple vendor or multiple instance for your provider?
For orchestrator, it actually is now still open. We are not deciding whether we'll have one or multiple vendors. This is something I don't know. For SDN vendors, it is actually because we have already purchased some SDN controllers, or they might already exist in some of our data center. That's why we may have different vendors for SDN controller. And also, as I mentioned, China is a huge country. You have to have different vendors to support this huge workload. I don't think any vendors now we consider they have the resource, they have the capability to support such a huge network in China. Yeah.
Yeah, so, so technically the controller must have all information in their database, must be single. But I'm just wondering how you can select multiple vendors and the multiple instance to control your whole infrastructure.
I know your question. Now what we're saying, at least we're hoping we can use the orchestrator, not only the NFV orchestrator, but also the SDN controller, SDN orchestrator that could solve this multi-vendor problem. But
You would just use the controller as an abstraction layer, right?
yeah.
You wouldn't use it for network flows.
Yeah, but I'm not from the orchestrator team, so I cannot speak for them. I'm not sure if I'm answering this question correct. But if you need more details, you can give me a name card. I can go to my orchestrator colleague. They may give you the correct answer. So I'm not sure if I answered that correctly.
Yeah, thank you.
Any other questions?
So,
There's a lot of vendors out there, like a lot of cloud vendors, in particular Amazon, who refuse to release this much detail about how they do things. Pretty impressive that a government who typically doesn't release a lot of information made this sort of information public. Was that to forward the rest of the industry, or is that just because you want to show off because you're awesome?
We are not awesome, I'm quite sure. I think everyone can do this work.
Don't be modest. A billion people in 9 months with integrated VNF and self-test and deploys. That is something that like nobody can do even in a lab environment. So like it's a pretty impressive feat unto itself. It's really across like you mentioned China's a big country. Australia's a big country. There's like 20 million people that live here. Like one of your Like, it's a bit of a, I'm just interested to know why you decided to come and show the audience this information. That must have only been two reasons. One, you're immodest and you want to show how good you are, or that you want to show people that it can be possible. This is anything to do.
We actually hope that we could promote this industry. You see that from this network, the work we have done, and also for the automatic onboarding system, we hope that we could also get support from vendors, especially on the integration part. We now see that we have lots of installers. They are totally different. That's something really a nightmare for us. We hope that we could have at least a unified configuration file. That's the first step. Maybe future a unified installer for us. We hope that this community could help us do something about that.
It just means a lot of plugins for user on, basically. I mean, that's what it will come down to. If you want to
Yeah.
use your OpenStack and then hope that you'll still need a controller or whatever, but like your abstraction. Because saying you have an API is one thing, but using it is another.
Yeah.
Like just appears like the way you're using OpenStack is probably a lot different to the way that a lot of the guys using compute are using it.
Yeah, that's the case.
So,
please.
if I understood it correctly, you are using this system only for testing, right? Are you planning to use this kind for CI/CD, so you can do continuous deployments on the live system, or testing on the live system even?
Yeah, that is also in the plan. Actually, now in our lab, we have 3 ticks that are under test, but also we also build a quite complete CI/CD system so that our developers can work directly on this system. When they find some bugs, they find that they should upgrade some test cases, they can use that system to upgrade. So this is a complete CI/CD system. And also, now we are only tested in the labs, but we are planning next year in phase 3 of our experiment network, we would like to propose this whole system to the 4 or maybe more provinces in China to have the actual operators to try if it fits our requirements, and that is the plan. I maybe can share more experience after that and see if we have any problems with this system that we need to improve. Yeah, please.
My question is, I saw you have all the test cases automated with virtual EPC, maybe virtual IMS, and all your infrastructure. If there's a plan or there's a community you're going to contribute this to, so other operators can share or we can contribute all together?
For the infrastructure testing, since we are based on OpenNFV test cases, which is already open sourced, so and also it is developed by China Mobile by ourselves. So it is okay that we could open source it. We can share the test cases and for other end users to utilize. But for the service testing, some of them are developed by China Mobile, but a lot of them from Ixia, Spirent, they have to utilize their chassis and maybe their virtual testing tools to do so. So it's on their decision, you know. I also know that Ixia is actually also contributing to OpenNFV Yardstick. They are working to provide the API so that the Yardstick framework can also utilize their chassis. So they are kind of having having the decision to contribute back to the open source as well. Yeah.
So, like you must be members of like the ONF and like the OEL projects, and so all your code goes upstream.
Not really. Upstream is like.
You'd be an OpenStack community member, you'd be an ONF member, you'd be an ODL member. I'm just saying the commits that you make don't necessarily make the code base of those controllers or platforms.
Yeah. Actually, you are asking my or my team.
You like China Telecom, full stop.
China Mobile.
China Mobile. Well, this platform in particular, because it utilizes obviously a lot of open source projects.
Uh-huh.
And you're committing a lot of code. How much of it does it make back into the main Git repo? Because I used to work for Brocade before they were disbanded. Basically, ODL was our go-to-market for our controller. But every code commit that we made always went upstream. And
Yeah.
you guys do something similar.
Yeah. That is also what we planned, but I don't know if I'm right, but now I see that OpenNFV, they having testing projects that we could contribute, and we are already contributing in those testing projects. And also, you know about the Dovetail, the CVP program in OpenNFV, they're doing the certification. We also hope that these test cases could be included in that, so it could be, OpenNFV can help us do the testing somehow.
So this is all this white box, or like it's all this white box stuff. It's not bought off the shelf, confused, whatever. Like you're using white box switching, you're using white box x86. You're not using vendor specified products.
Not that case. We think we can.
I saw some Huawei stuff before, but
Yeah.
just wondering, because I mean the idea, I guess, for most of us, the utopia is that we can buy any platform we want.
That is, I think that is our ultimate goal, but it is not quite a reality yet. We actually have some trials on white box during the experiment network, but the experience is not that good.
Because the VCD story can actually be a viable one now because of like the new Xeons that have come out that provide multiple threats for VNS. So it's just really interesting to see how somebody actually did it properly.
Yeah. Okay.
So on one of your slides, you have multiple edge sticks, right, controlled by SDN controller.
I'm sorry?
In one of your slides, you have multiple edge sticks controlled by a SDN controller. So you have 4 SDN controllers, vendors, right? So how do you group these edge sticks, and how do you figure out which SDN controller to use moving forward?
You mean in edge sticks, the SDN controllers?
Yeah.
And you actually addressed the huge problem for us. We have some thoughts. Probably for each edge stick, we will have one SDN controller, but that is actually wasting the resource. Because now we have SDN controllers that maybe can control 2,000 more compute nodes, but in edge sticks, there might be only 50 compute nodes, so it is wasting resources. We also have another idea is that we might use one SDN controllers across different edge sticks. They might be quite in short distances with each other. But then we have the problem is that we have the different neutrons visiting the same controller. They have the problem with the data things and that. So we're working on those things. I think we have a solution back into China Mobile lab. We actually self-developed our own SDN controller based on ODL, and we are doing our own solution on this problem. But it is not out yet. It is still under testing.
Okay, thank you.
Okay, I think we have to stop here. So if you have more questions, you can come up and ask me and Wang Xu. Thank you.